Today we are going to show a fast integration solution between a high-quality photovoltaic plant and the SCADA software ActionNET. To create a new photovoltaic plant quickly, we need to use the ActionSun template, which already contains a standard database, a component library, and dynamic screens. In the project environment, let's verify the database structure that is already built into the solution. We can utilize the generic photovoltaic plant structure or create new ones using base templates that categorize variables into status, measures, communication, and commands. The available templates comprise circuit, combiner box, concentrator inverter, meter, NCU, security camera, tracker, transformer meter, and weather tower. We are going to create a photovoltaic plant composed of 1 connection circuit and 7 plant circuits. Each plant comprises a Siemens relay, a smart logger concentrator, and 3 or 2 Huawei inverters. The 72 SunTrack trackers are controlled by an NCU, and the weather station is monitored by a Novus data logger. To ensure security surveillance, there are 23 security cameras. The feature that will help us generate all database, supervisory points, alarm items, and historian registers is called Equipment Gateway. With this feature, we can fill in the editing fields to create one IED at a time or import all IEDs at once from a configuration file. To utilize the Import File option, click on the 3-dot button and select the equipment's CSV file. This file defines the name, asset level, equipment model, and communication configurations for each equipment. After selecting the file, click on Create and wait a few minutes until ActionNET finishes importing all IEDs, alarm items, supervisory points, and historian registers. Now we can see a new scenario at the assets level called PV spin, structured as defined in the import file. On the Objects tab, we can see all 130 created IEDs and navigate through their templates. Additionally, we can configure the ActionSun object. There are 2 groups that need to be configured. The first one is the display settings, in which we define the screens that will be available for access during runtime. The second one is the settings, in which we define general information such as the name of the complex, the geographical coordinates, the number of plant circuits, which equipment are in use, their models and arrangement in each plant, and others. The Historian tab displays all 2801 historian registers divided into categories. To ensure a good communication with all the equipment, a meticulous study of the equipment and protocol documentation is necessary. On the Channels tab, we can see all the protocols being used, such as Modbus, DNP30, and IEC 870-5104. The Nodes tab displays all created IEDs and their communication parameters. And the Points tab shows all 43364 supervisory points generated, their communication address and access type. On the Groups tab of the Alarms module, there are the main groups used to notify active, normalized, warning, and critical events and alarms. The Items tab displays all 8088 alarms and events generated. In the Scripts module, we need to enable certain scripts based on the equipment models being used. Finally, it's necessary to configure the non-dynamic screens with the desired layout. For easy setup, there is a component library with a list of equipment models. After importing the component onto the screen, you simply need to link it with the Coret tag. The non-dynamic screens include Architecture, Single-line diagram, and Solar single-line diagram. Now let's run the application and navigate through the screens. The first screen displays the general information of the complex. On the left side, there is a dynamic table showing the state of each circuit plant. Following that, there is an interactive map, a trend chart of the active power throughout the day and information about the weather station. The selection menu enables navigation through the available screens at any moment. The architecture screen shows the communication state of the equipment. The single-line diagram shows the state and active protections of each circuit breaker. To command the equipment, click on the circuit breaker and select the command on, off, or reset. To access more detailed information about the status, protections, and measures of each circuit, click on the title of the bay. The solar single-line diagram shows the circuit of each plant and the status of the inverters. The inverter screen is generated dynamically and shows the state of the strings and the details of each selected inverter. The NCU screen monitors the state of NCU and RSU as well as the communication via the Ethernet link. It also allows for the control of the panel's position. The tracker screen is generated dynamically and shows the state and position of all trackers, as well as the details of each selected tracker. The solarimetric station displays real-time weather information and trend charts of irradiance and temperature throughout the day. The security surveillance screen is generated dynamically and shows the communication state of each security camera. It also allows the remote access to the video images. Beyond these screens, there are the default screens of the ActionNET, such as the real-time online alarms and the real-time online events. Operation Summary, which displays user actions. Tags Summary, which uses the filter to define the tags to be searched. Event Summary Historian. Measures Historian, which uses the filter to define metrics and the period to be searched. Trends, which displays tabular measures in an interactive trend chart. The interactive controls include changing the scale, zooming in and out, and scrolling through time. The ActionNET SCADA can be customized and adapted to fit each client's reality. Want to learn more? Contact us.